In a Harvard School of Public Health survey, 2105 of 10,904 randomly selected U.S. college students were classified as abstainers. Construct and interpret a 99% confidence interval for P, so the X proportion of college students in the U.S. who are non-drinkers, right? And follow the four-step process. So our sample proportion of college students in the U.S., so sample proportion, P hat, so I guess A, right? P hat is equal to 2105 over the 10,904, right? And that is approximately a 0.193. All right. So what we want to do, state we want to estimate the actual proportion of all U.S. college students who are abstainers, right? Okay. At a 99% confidence level. All right. So that's what we want to do. We want to construct this 99% confidence interval given a one sample proportion, right? Given a sample proportion from one of the samples, right? Yeah. Okay. So first, what we need is we need to do our plan. Okay. So we should do a one sample z interval, right, for the population proportion, right? U.S. students who are abstainers, right? If the conditions are met. All right. So let's go ahead and get those conditions. So the first one is random. Was this survey done randomly? Well, it says so in the problem, right? 2105 of 10,904 randomly selected U.S. college students. So definitely random. So students were selected randomly. Check, right? The next one is normal. So for normal in this one, it's going to be n times p hat, since that's what we have, and we're using this in order to find our 99% confidence interval for the actual population proportion. So this has to be bigger than or equal to 10, and n times 1 minus p hat has to be bigger than or equal to 10 to assume normality, right? Assume that the distribution is approximately normal. So this is 10,904 times 2105 for the proportion over 10,904. 10,904 over 10,904 is 1, so that's 2105, and that is, of course, bigger than or equal to 10. And then the next one, this is going to be 10,904, and then 1 minus p hat is going to be 8,799 over 10,904. And of course, this is 8,799, and this is bigger than or equal to 10. So we can assume that the distribution is approximately normal. Now, the last condition is independence. So let's go independence. And that is just the 10% condition that we've been using in the past. All right. So remember, the 10% condition said that n has to be less than or equal to a tenth of big N. In this case, big N is the number of U.S. college students, right? So remember, little n was the sample, size, which was 10,904. And that, I think you can see, is clearly less than a tenth of the number of all U.S. college students. We can even rewrite this as 10, or I guess 109,040 less than or equal to n, and we can definitely assume that that condition is met. So those are the three conditions required. So all conditions are met. So now let's go ahead and go to our do part. So what we're trying to do is we're trying to find two areas of equal area, okay, where this area in the middle is 0.99, okay? So these areas are going to help us find our margin of error for our 99% confidence interval. So in order to get these two areas of equal area, we know the whole area of the curve is 1, and we could subtract 1 minus 0.99 and then divide it by 2 to find those equal areas, those areas of equal area. So this is equal to 0.005, right? So that means this area here is 0.005, and this area here is 0.005. And for our formula, so here is actually the formula for determining margin of error. We know that z star, so this will be negative z star, and this will be z star. So z star times the square root of 1 minus, I'm sorry, it's p hat times 1 minus p hat over n is always less than or equal to the maximum margin of error, okay? So for our confidence interval, we know, so this is the 99% confidence interval. This is going to be, it's going to be p hat plus or minus this margin of error here, right? So it's going to be a z star times the square root of p hat times 1 minus p hat all over n. So, of course, for this formula, we have the p hats and we have the n, but we need to find that corresponding z star for the 99% confidence interval. All right, so what we do is we go to our table. All right, so we try to find the z-score that aligns with the probability 0.005. So I see here 0.0049 and here 0.0051. And that aligns with the z-score negative 2.58 and negative 2.57. So we can see that 0.005 would be right in the middle of that. So a good z-score would be negative 2.575, right? So negative equals negative 2.575. And this, since this is symmetric, right, this is just going to be the positive 2.575. So we have everything. So remember, our p hat was the 2105 over 10,904, but we're just going to use our estimate. So that was 0.193 plus or minus, and then our z is 2.575 times the square root of p hat, which was 0.193, and then 1 minus p hat is going to be 0.807. And that's all over 10,904, right? So this is roughly 0.193 plus or minus 0.01. So that means 0.01 is going to be our margin of error for our confidence interval. And this is equal to, so 0.193 minus 0.01, right, is 0.183. And 0.193 plus 0.01 is going to be 0.203. So we can see that the confidence interval, we are 99% confident that the actual proportion of U.S. college students, right, would be between about 18% and 20%. So let's go ahead and write that in our conclude. So let me scoot down a little bit. So conclude. Okay, we are 99% confident that um, the actual proportion of U.S. college students who are abstainers is between about 18%. I guess I'll just put about 18.3% and 20.3%. Okay, so we are very pretty confident that 99% confident that the actual proportion of U.S. college students who abstain from drinking is between about 18.3% and 20.3%. Now we had a part B for this problem. A newspaper article claims that 25% of U.S. college students are non-drinkers. Okay, so from use your results from part A to comment on this claim. So we can see that it's not very likely that it's going to be 25% of the actual proportion of college students in the U.S. are abstainers, right? Because we're based off of that sample, that one sample, we're 99% confident the actual proportion would be between about 18.3% and 20.3%. So we can just write that basically. Okay, so 0.25 does not appear in our 99% confidence interval, right? While it is possible that 25% are abstainers, right? It is not very likely. All right. And that's basically it for how to find a confidence interval given a sample proportion. We're trying to find a confidence interval for the population proportion given a sample proportion.